Okay, so good morning. So we'll start section 5. Section 5 will have around 8 to 10 questions. Very easy to score. Okay, they are not tough questions. There will be some open book questions and there will be some closed book question also. So section 9, if we take section 9, we have 4 chapters, but the same will repeat in 577 all actually. PT, MT, RT, UT. UT, we have only thickness gauging, not the full UT in section 9. And the next one is the general requirements. Now, majority of the question, I told they are asking 8 to 10 questions. At least 3 to 4 questions based on the radiography test. So radiography testing, we should know in detail. Then PT, MT all will have 1 or 2 questions. And UT also will have 1 or 2 questions. So this is the general coverage. Now let us start with the general requirements. Article 1. So we have Article 1 general requirements. Article 1 general requirements. Then Article 2 radiography testing. Article 6 penetrant testing. Article 7 magnetic particle testing. And SE 797. Article 4 and 5 actually UT, but that is not part of our exam. SE 797 thickness gauging, and this there also only one paragraph is important. Now coming back to the Article 1, only one thing you should know. You remember in section 8, only UT and RT technician need to be qualified as per SNTTC only, level 2 as per ASME section 5. Whereas PTMT technician can be qualified directly by the manufacturer. No need to follow section 5. Now, if the reference code, here our reference code is section 8. If the section 8, you have to follow section 5. What section 5 says? The person shall be qualified in accordance with the employer written practice. That is the key word. The employer should write a written practice. So what the written practice will have? How we are going to qualify the NDT technician. That means how many hours training, how you are going to conduct the exam, how you are going to evaluate all this. So exam, if they are asking, NDE personnel shall be qualified in accordance with, I give 4 options. Reference code requirements option A, option B as per ASME section 5, option C as per SNTTC 1A, option D as per CP 189. Which is correct answer?
Yes.
Again, I will repeat. NDE personnel shall be qualified in accordance with option A, written practice, option B, reference code requirements, option B, reference code requirements, option T, SNTTC 1A, option D, CP 189. Reference code requirement. That is the correct answer. What reference code says you have to follow. If reference code is not there in the answer, then written practice is the correct answer. SNTTC 1A, when it will become correct answer, when both of them are not there in the answer. Suppose written practice also not there in the options and a reference code also not there in the option, then it will be SNTTC 1A. Okay, please remember this chain. If you take the chain from reference code says follow section 5, section 5 says follow written practice. How to write a written practice as per SNTTC 1A. And the chain last link தான் SNTTC 1A. The மூணுமே இல்லைன்னா ஆப்ஷன்ல you have to go for a SNTTC 1A. You understand this? In interview, suppose somebody asking how you will qualify the NTT technician, it is not SNTTC as per reference code requirements. Suppose they are asking why you are telling reference code requirement, because section 8 says PTMT no need to follow written practice or section 5. So reference code only we will follow. Okay. See, highlight this paragraph. This one, this is closed book question. For those documents that directly reference this article for the qualification of ND personnel, the qualification shall be in accordance with their employer written practice, which shall be in accordance to one of the following documents. The key word is employer written practice. That is closed book question. SNTTC 1A 2016 edition, then CP 189 or ACC. Highlight this paragraph. So written practice you can write as per SNTTC 1A, CP 189 or all this. Highlight. So now we'll go to the Article 2. So Article 2 radiography generally will have at least 3 questions. They are asking at least 3 questions from the radiography. Now, if you see, it is not a NDT class. First, I am explaining this is not NDT class. We are not going to much detail, just important things for exam. Okay. So this is the basic radiography arrangement. To take radiography, we need 3 things. We need a source, we need an object, we need a flow. Object is your part, vessel, pipe, plate, anything. Now, let us discuss what is the basic principle of radiography testing. What is the basic principle of radiography? Okay.
The radiation.
Now, okay, I will ask you the simple question. I have a source. I have a object. Object is the uniform thickness plate without any defects. Okay, without any defects. Okay, then I have a film. So the radiation passes through the object and fall on the film. See, what radiography we are using is a black and white radiography, right? What image will be formed on the film? Now, again, I will repeat. I have a source. Object is a uniform thickness plate without any defects, and I am radiographing. What image you will get? White image or black image? Black image, white image. Yes, sir. Any other answer? No, I ask you. Okay, density. Okay, the answer is no image. You will not get any image actually. Image means something you can see. For example, this wall you can see white wall. You can see some images there. Image in radiography means a black color on a white background or white color on a black background. If entirely uniformly black or entirely uniformly white, there is no image. When that's why I specifically said a uniform thickness without defect, you will not get any image. Now the question is, when I will get a white image? When you will get a white image? When the thickness difference is more. See, actually the basic principle, what is the basic principle? Difference in radiation absorption. That is the basic principle of RT. No, you said it is radiation absorption. It is not radiation absorption. Difference in radiation absorption. If uniform absorption, you will not get any image. Only if there is a difference, then you will get an image. Then what difference means? If there is a thickness difference, you will get an image. If the material density difference, material density difference, you will get an image. Even atomic number difference, you will get an image. For example, I have a weld here. So weld means the thickness is more because of the reinforcement and so weld, what image it will form? White image or black image? White image, because when the thickness more, absorption will be more, which will create a white image. Then high density, for example, you can, all of you know that tungsten inclusion will be a white image because tungsten density is higher than the steel. Opposite, a thickness reduction or density reduction will result in a black image. For example, what are the thickness reduction? Undercut, root concavity, okay, lack of vision, lack of penetration, slag, porosity. Slag actually density difference. Slag is a non-metal, so low density will give the black image. So this is how radiography works. Now, if you have any doubts, you can ask me. I will explain, but it is not full NDT class. Just exam point of only we are going to cover it. Exam question will be based on these things only. Question based on the density, then sensitivity, geometric unsharpness, then techniques, then procedure. So based on this only exam question generally they are asking. We will go one by one. Okay, this is the 5 topics only exam question they are asking. If you want, write it, no problem. Geometric unsharpness. Geometric unsharpness. And the techniques. Then finally, procedure based questions. Right, we'll go one by one. See, what is material density? Density of formula and material density of formula. Mass by volume. Okay. But that is not the density. Here we are talking about the radiographic density. That is different entirely. First, what is the definition of radiography? What is density means? How much it is block? Simple. எவ்வளவு கருப்பா இருக்குங்கிறது தான் density. So radiography completed. Okay. Now, what is radiographic density? Degree of film blockening. How much the film is blocked? More block, more density. Less block, less density. Very simple. If it is white means less density, darker means more density. Is it English or last? Is it? Okay. So I will write here. So radiography density degree of film blockening. Now let me complete after you can write. Now, how will measure the density? How will measure the density? By using densitometer or film batch density strip. Density strip. Film batchங்கிறது சேஃப்டிக்கு யூஸ் பண்றது. ஓகே. அது வேற. ஓகே. So densitometer or density strip. We will use a densitometer or density strip. There is a theoretical formula. That formula is not important. Suppose anybody want to know, this is the formula. D is equal to log IO by IT. This is the formula. That formula is not required for it. Now, next one is important. What is the specified density? Specified density means as per section 5. What is the acceptable density limit? Acceptable density limits. There are 3 values. If you are doing radiography with the X-rays, it is 1.8 to 4. If you are taking radiography with the gamma rays, it is 2 to 4. But if you are doing a composite radiography, that is 1.3 to 4. What is meant by composite radiography? Multiple film techniques. In one cassette, if you are putting 2 or more films, that is called composite. Each film should have minimum 1.3 radiography. Please remember density, there is no unit. You know this formula, it is a logarithmic comparison actually. Density is a number 1. Another important thing is, so this value you have to remember, it may be closed book only. These are closed book. Suppose this is your film. You can see at the center, you can see the weld. This is your weld. And I can see the IQ image here. Wire IQ, suppose I use it. Now the question is, where I will measure the density in the film and record it on the report. For example, first question, weld or base metal? Which one we have to see? Report, they will measure some density value they are writing. Which density that is? Weld density or base metal density? It is a weld density because weld is only our area of interest, point number 1. But we have a very lengthy weld in the film, where I will measure the density and write it on my report. Near the IQI. In the IQ area, on the weld, you have to measure and write the density on the report. Okay. Now, for example, this film is taken on gamma rays. See, what is the gamma rays acceptable range? 2 to 4. Suppose here, say it is 3. Is it acceptable or not? Acceptable, straightforward. But there is one more condition given in the section 5. Suppose other area, here I am measuring, it is showing 2.4. Logically, you say, because it is within 2 to 4, it is acceptable. It is not like that. There is one more condition given in the section 5. Other area density cannot vary more than plus 30% or minus 15% from that IQ area. If you take here, what is the density here? 3. If you calculate plus 30%, you can calculate later, it will come 3.9. If you go minus 15% from 3, it will come 2.55. Now here, what is the value here? 2.4. This is rejected. The film is rejected. Then what you have to do? It is not a rejectment, there is no repair. But because of the density is rejected, we have to take one IQ here, another IQ here. Then we have to reshoot it again. We have to keep 2 IQs because the density variation area. This is also important. Again, I will repeat. The definition of density is degree of film blocking. That is the definition. How we are measuring density, densitometer or step-by comparison film or density strip normally we call. You should know the specified density range. X-rays 1.8 to 4, gamma rays 2 to 4, composite mean multiple film 1.34. This is a closed book question. There is a theoretical formula they never ask in the exam. D is log IO per IT. It is not given in the code itself. Okay. Next one, important. From the IQ area, other areas of film cannot vary by more than 30% or less than minus 15%. Plus 30%, minus 15%. If it exceeds that limit, then you have to keep additional IQI and again take radiography. These are the things you should know about the density. Okay, so please write this. ஆமா plus 30 ஆன okay, so that is about the density. Now we will go to the sensitivity, right? Sensitivity and the quality of radiograph both are same. சரிங்களா? சரிங்களா? See, radiography sensitivity. Or we call it as a quality. Now, how we will measure the what is the definition of sensitivity is ability to detect a small defect. That is the sensitivity general meaning. How we will measure the radiography sensitivity? IQI, or another name of IQ is the penetrometers. Now, image quality indicators or penetrometer, there are many types, but as per ASME, we should know about 2 types. Okay, so if you see here, so this is called wire type IQI, and this is called the hole type IQI. Okay, this one only as per ASME. Now, wire type IQI, in a sleeve, plastic sleeve, we will have 6 wires. Here it is 7 wire. It is a European standard. It is not the ASME American standard. Here you can see 1, 2, 3, 4, 5, 6, 7. But American, it will be only 6 wires. Now, the 6 wires, we have 4 sets. Set A, B, C, D. So, what is the size of the wire? If you go to the section 5, you can see page number 42. You can see here wire identity. Set A, wire number 1, the diameter here in inches, bracket mm. So, I will put mm, 0.08 mm. So, 1 to 6 set A, 6 to 11 set B, 11 to 16 set C, 16 to 21 set D. So, the last wire, if you see 21 wire, it will be 8.13 mm. First wire is 0.08. So, there is a 100 times increase. This is one the wire, this one. Wire type. Now, if you go to the hole type, you can see hole type, you can say it is a small plate and there will be a number here. What is the number? For example, here it is 17 means the thickness of the plate is 17 mil. You know already what is mil or thou. 1000 mil is equal to 1 inch. 40 mil is equal to 1 millimeter. 17 means less than half millimeter. So we have 3 holes. The center hole is called 1T hole. This is 2T hole. 40. T means thickness. 1T hole means the diameter is 17 mil. 2T means the diameter is 2 into 17, 34. 4T means 4 into 17, 68. Okay, this is the one. Now, what are the various numbers we have? Again, same page in section 5, you can see here. From 5, it starts from 5 and end up to 280. So, this is the thickness. This is the 1T hole diameter, 2T hole diameter, and 4T hole diameter. Okay, so 1T, 2T, 4T hole. Now, next one. What are the important points you should know this? First thing, IQ selection based on the same material group. Point number 1, IQI selection, same material group. It is not same material, same material group. Same material group means carbon steel, alloy steel, stainless steel, all same IQ only. We don't have different IQ for carbon steel, different IQ for this. Steel group means same. For example, steel and steel alloys. Steel and alloys. Next one, for IQA selection, you can add reinforcement and penetration if you want. Backing strip should not be added. If you are using backing strip, so can add, it is not option, add reinforcement and penetration thickness. Backing strip should not be added. Backing strip thickness not added. Thickness should not be added. That is point number 2. Point number 3, how to keep the IQI. Wire IQI, transverse. Transverse means perpendicular to the weld. To the weld, hole type IQI, IQ parallel or perpendicular. Parallel or transverse. That is the same condition. This is important. It is regularly asked. How we will keep the wire type IQI? So you can see this picture. This is the way you have to keep the wire type IQI. Across the weld, on the weld, so that the wires are perpendicular to the weld. It is not a hole type, it is step edge actually. Hole type also they will keep adjacent to the weld, or you can keep across the weld also. Now the next question is, how many IQA record in each film? How many record? Minimum one IQA in each film. But there is an exception for panoramic, minimum. What is panoramic? Keeping the film as a source inside, taking 360-degree radiograph in one shot, minimum 3 IQIs. No, each film no need to have. So you can keep 3 IQs. Yes. Then what is the next condition? Where to keep the IQI? See, if you see here again, so if we take radiography, this top side is called as a source side, this bottom side is called as a film side. IK placement preferably source side. If not possible, you can keep it on the film side. So IK placement preferably source side. If not possible, film side you can keep, but there should be some letter. What letter they will place? With the letter capital F. Letter capital F. So near the IQ, there should be a F to indicate it is kept on the film side. These are the key points you should know about the sensitivity. Okay, this is one of their favorite area to ask questions. So please cite this. அது மெட்டீரியல். ஒண்ணுங்கிறது மெட்டீரியல் குரூப், ஏங்கிறது இந்த ஏபிசி. எஸ்எஸ்க்கு இருக்குது, பட் அது வந்து இது யூஸ் பண்ணலாம். Okay, other things we will go through the code book. Okay, I told you procedure, techniques, then the geometric unsharpness. One more thing is backscattering. Right. So please go to the code book, article 2. Please take article 2. Highlight this one, procedure. Now, what are the things? See, for radiography, we need a procedure. Okay, but a procedure qualification is not required. PT, MT, UT, we need a procedure. We need a procedure qualification also. What is meant by procedure qualification? You have to demonstrate. You have to take a test plate and do PT and confirm that the procedure is correct. Okay. How this one? Radiography examination shall be performed in accordance with the written procedure. Each procedure shall include at least the following information. You can see what should be written in the procedure. Material type and thickness range, isotope, source to object, distance from source, source size. Now the exam question they ask, what they will ask, they ask, which of the following is not a part of radiography written procedure? The answer is geometric unsharpness. If you see here, the list geometric unsharpness is not there. Okay, generally the answer is geometric unsharpness. No need to return in the procedure, but you should cover all these things in the procedure. That is open book. So write geometric unsharpness. You can write nearby geometric unsharpness not required. UG geometric unsharpness. Then what is meant by backscattering? See, First, what source we are using for radiography? X-rays and or gamma rays. X-rays and gamma rays here. What is the difference between X-rays and gamma rays is origin of production, how we are producing. X-rays are when fast moving electrons stopped by a target, X-rays are generated. Gamma rays are radioisotopes. But other things all common actually. What are the common things? They are part of electromagnetic radiation. They travel in straight line. They react with the material. They react with the human body. They can react with the film. That's why we are getting image. They can be scattered. Scattered means they can change the direction by reflection. See, we have many types of scatter. You can see this is called as the internal scatter. Metal can be reflected from the internal part of the object. To filter the internal scatter only, we are using the LED screen. You know, LED screen, front and back. LED screen, the purpose is to reduce the exposure time and filter the scattered radiation. That is the second purpose. Now, the next one scattering is called side scatter. From side objects, there may be scattering. The third one is very important, back scattering. See, what is meant by back scattering? When you are taking the radiography on your floor or on ground, the radiation will hit the ground and come back, hit the floor and come back. Then what is the problem with the back scattering is it can create unwanted dark images. It look like a porosity in the radiograph. So as per section 5, you should know whether the back scatter is present or not. How you know the back scattering is present? You will keep the letter B behind the cassette, the letter B. When radiation come through the B, it cross through the B, so we will see the white B image on the film. A white B image is not acceptable. So you can see here, if you take B image, this is the B image, white in radiography, we call it as a light, white light both are same, or pale image. Not acceptable. So if B appears on the film like a white color, white or light both are same, light color, or pale means very light color. That means back scattering is present. We have to give additional protection and take radio. What is the additional protection? They will use a lead sheet to observe this one. Suppose the B is a dark color or dark or black both are same, black color or no image. There is no B image. Then the radiography is acceptable. Now you understand no image means there is no backscatter. But there is one more thing. If you are not keeping B also, image will not come. That you should ensure they are keeping properly. Okay. But what is dark image and black image means? See, this is your B means radiation coming behind, because lead is the high absorbent, will create a white image. But radius reflection from the B will create a black image. So a black image means it is not from the behind, it is a reflection from the B only. So that can be accepted. So please write this one. This is also important. Backscatter. Yeah, Bன்னு ஒரு நம்பர் தெரியணும். Bல வந்து ஒயிட் கலர்ல B தெரிஞ்சிச்சுன்னா ரேடியோகிராஃபி ரிஜெக்ட் வைக்கணும். அது வந்து மேண்டேட்ரி. சைட்ல தேவை. இந்த ஒர்க் ஷாப்ல ரேடியோகிராஃபி எடுக்கலாம், பங்கர் வாங்கல, அங்க வைக்க சொல்லணும், இன்சிஸ்ட் பண்ணணும். கேட்டா வச்சிருந்தா வரலன்னு சொல்லுவாங்க. Okay. Right. So please highlight this one. Backscatter radiation. Again, close book question. A lead symbol B with the minimum dimension of 11 mm is in height and 1.5 mm in thickness shall be attached to the back of each film holder during each exposure to determine if backscatter radiation is exposing the film. Highlight this 5 lines. That is close book question. Then page number 42. So this already we have seen. Now page number 43. Please go to the page number 40. When you are viewing the film, you should have the film viewer. What should be the intensity of the viewer? Intensity means power. It should be able to read the specified density range. What is the density range specified? I told you maximum 4. It should be able to read the maximum 4. Okay, highlight this one. This is close book. Viewing facility shall provide the subdued background lighting intensity that will cause reflection, shadows, or glare. And these 3 lines are actually close book question. Equipment used to view radiographic for interpretation shall provide the essential IK hole or designated wire sizzle in the specified density range. This is the key word, specified density range. Now densitometer. Now another question. Densitometer shall be calibrated in accordance with option A, national standard, option B, international standard, option C, ASME standard, option D, ASNT standard. Which is the correct answer? National standard. So generally calibration always to the national standard. Every 3 months we have to calibrate it. That is calibration. But every day you have to check whether it is properly working. So highlight this one. Densitometer shall be calibrated at least 3 months during the use as follows. A national standard step tablet or step edge film traceable to the national standard having at least 5 steps. That is close book.
National standard,
Each national. India we have a national standard. So that is close book question. Now this is again close book. Periodic verification, highlight this one. Periodic calibration verification shall be performed at the beginning of each shift, after 8 hours of continuous, or after change of apertures, whichever comes first. So every 8 hours you have to check it by using that certain strip whether it is working properly. That is close book question. Now coming back to techniques. See, what are the basic techniques we have? Single wall, single image, double wall, single image, double wall, double image. Now, what is single wall, single image? Radiation pass through one wall like this plate or pipe. One wall and we can keep the film. This is single wall, single image. But for take pipe, single wall, single image, you should have access inside. If you keep the single wall, single image at the source at the center, it is called as a panoramic. Double wall, double image means radiation pass through 2 walls, but only the wall close to the film is recorded. You can see here, this is double wall because source we are keeping here, but only this image will be recorded. That is double wall, single image. Double wall, double image means for small diameter pipe. This is exam question. Below what diameter double wall, double image is allowed? Answer is 89 mm and below. 90 mm and below only double wall, double image. There are 2 techniques in double wall, double image. Elliptical, superimposed. So if this is the double wall, double image, okay, this is ellipse and this is superimposed. So please go to the code book, highlight this first line. A single wall exposure technique shall be used for radiography whenever practical. That is the preferred technique. Then this is important, close book question, double wall viewing for materials and for wells in components 3.5 inch or less than nominal outside diameter. A technique may be used in which the radiation passes. This is the 89 mm or less. That is important. Double image. Double viewing means double image. DWDI. This paragraph is important. Now, next one is geometric unsharpness. Recently, they started asking this as a closed book question. Before, they used to ask as a open book question. See, first you understand what is geometric unsharpness. Definition, sharpness, both are same. Unsharpness is opposite. See, this is the sharp. This is called unsharpness. The edges are not sharp, blurred image. There will be some unsharpness in the radiography because of the source size, source to film distance. But how much it can be accepted? You have to remember this value because recently they started asking in close book. Less than 50 mm. I will put it in mm so you can understand. Under 50 mm, 0.51. 50 to 75 mm, 0.76. 75 to 100, this two only they are asking actually, 1.02. Greater than 100, 1.78. Regularly they are asking, what is the maximum geometric unsharpness allowed for 2-inch thickness? What is the answer? 2-inch thickness, what is the maximum unsharpness allowed? 0.76. இது வந்து under 2 inch. Under 2 inch means not 2 inch not included. If they ask 2 inch, answer is 0.76 or 0.03 inch. This you have to remember. Recently, they started asking closed book. Before it was asked in the open book. Then location marker, these are not important. Then generally, see, what are the mean by location marker? You know the numbers 5, 10 to traceable or the welder identification. Which side you have to keep? Generally, practically, we will not give any importance. But code says you should keep on the source side. Only one condition. This one we can keep film side. See, highlight this one, this sketch. Curved components with the radiation source distance greater than the radius, we can keep on the film side. அதாவது சோர்ஸ் வந்து சென்டரோட பெனாரமிக்னா சென்டர்ல வைப்போம். சென்டரோட ஷிஃப்ட் பண்ணி வச்சிங்கன்னா ஃபிலிம் சைடு தான் வைக்கணும். லொகேஷன் மார்க்கர். You can see in the next paragraph. This is the open book question. Film side markers. Location marker shall be placed on the film side when radiographing either a curved or spherical component whose concave side is toward the source and when the source material distance is greater than the inside radius. Highlight this one. I think it is not highlighted. B1, page number 46 la B1. Highlight this one. அங்க இருக்கு பாரு அந்த சைடு. அதான். B1 highlight and mark it as a open book question. Location marker shall be placed on the, generally it should be kept on the source side. But if the source film distance is more than radius, then you can keep on the film side. Film side it should be kept. Mark it as a open book question. Then IQI, I already explained. Highlight the first 3 lines. A. Weld with reinforcement. The thickness on which IQ is based on the nominal single wall material thickness plus weld reinforcement thickness estimated to be present on both sides of the weld, ID and OD. So you can add the reinforcement. Even ID means penetration also we can add. Then highlight this one. Backing rings or strips shall not be considered as part of the thickness in the IQA selection. You should not add the backing strip. Suppose the weld is flush grind, you cannot add the reinforcement. Yes, because there is no reinforcement. Weld without reinforcement, the thickness on which IQ is based is the nominal single wall thickness. Backing rings or strips shall not be considered. Then source side IQ, highlight the A, T277.1. The IQ shall be placed on the source side of the part being examined, except for the condition described in the B. Then this is important, film side, where inaccessibility prevent hand placing IQ on the source side. The IQ shall be placed on the film side in contact with the part being examined. A letter F shall be placed adjacent to or on the IQ. The film side you have to keep the F. That is closed book. The next page, this is how to choose the IQI. Again, this table, sometimes they are asking open book. For example, I will write one question. Base metal thickness say 0.5 inch. Reinforcement 0.1 inch. Backing strip thickness 0.2 inch. Now I am asking a question. If source side wire type IQI is used, which of the following sets should be, how many wires should be visible in the radiograph? Okay, I will write like this. How many wires should be visible in radiograph? Try to answer this question. Question Purida. Base metal thickness we have given, reinforcement we have given, backing strip thickness given. If you are giving source side wire type IK is used, how many wires should be visible in the radiograph? Let us check how many people are answering correctly. So answer is 8. Any other answer? 8 is not correct answer. Okay, I will explain, no problem. So first, you should know we should add these two things. This should not be added. Correct, Dana? So if you add thickness, what will be this one? 6 inch. Now, if you go to the 0.6 inch, it will come 0.5 through 0.7 side. Source side, what is the answer? 8. I didn't ask which wire should be visible. If the question asks which wire should be visible, answer is 8th wire. Read the question. What is the question they asked? Then what is the answer now? எந்த ஒயர்னு நான் கேட்கல, எத்தனை ஒயர்னு தான் கேட்டிருக்கேன். எத்தனை ஒயர் தெரியும் ரேடியோகிராஃபில் அப்படின்னா என்ன ஆன்சர்? Okay. See, what you have to do, so you have to first find the wire number. What is the wire number? If found 8. Now you have to check which set it belongs to. So let us go back. So 8th wire is set B. Now, if the 8th wire is visible, automatically 9, 10, 11 also visible because they are the higher diameter wire. So answer is 4. How many wires now? 4 wires. Mandatory wire 8th. 8th is visible now. All higher diameter will be visible. What are the higher diameter? 9, 10, 11. So 8, 9, 10, 11. The answer is, it is not 8th 4 wire. Which wire should be visible? If they ask, the answer is 8. How many wires should be visible? Answer is 4. புரியுதுங்களா அந்த லாஜிக்? இவ்வளோ டஃபாலாம் கேட்கறது இல்லை, பட் கேட்ட ஆன்சர் பண்ணுறது. எங்கள் கொஸ்டின் பேங்க்ல இருக்கும் நிறைய கொஸ்டின் இந்த மாதிரி.
அங்க வந்து 8ங்கிற ஆன்சர் இருக்கும் இல்லையா?
ஆமா, 8 இருக்கும். Hole type you can easily identify. Now, what is the essential hole? This is one of the regular closed book question. Which hole should be visible? 1T, 2T, 4T, 2T. Always 2T is the essential hole. Okay, you can see here this table. எழுதுறீங்களா? அதை எழுதிட்டீங்களா? Okay. See, NDT questions, they will not ask basic on the general NDT theory, only code requirements. The question will be what is the said in the code only. Unless sometimes even experienced people find it tough NDT questions. Because they're asking only code requirements, not the general NDT theory. Okay, right, we'll go back. So this table, I told you, highlight this table. This is open book question. Maybe they ask the selection. Sometimes they ask which wire should be visible, simple. You know, this is also important. What is the essential hole? Whether it is a film side or source side, it is always 2T. 2T, this is a closed book question. Which is the essential hole when you are using hole type IQA? Answer is 2T. 2T must be visible. When 2T visible, naturally 4T also will be visible because it is a higher diameter. 1T, it is not mandate. Then this is important. Placement for weld IQA. Wire IQA shall be placed on the weld so that the length of the wires are transferred to the longitudinal axis. That is closed book question. The number of IQA, highlight this one. When one or more film holders are used for an exposure, at least one IQA image shall appear on each radiograph except as outlined in B. B special cases for cylindrical component where the source is placed on the axis of the component for a single exposure. At least 3 IQAs spaced approximately 120 degree are required under the following conditions. So 3, 120 degree. That is closed book question. Then dense next one. Shim under hole type. This is not important. And this is important. Density limits. You can see this fifth line. The area of interest shall be 1.8 minimum for single wheel film radiograph made with an X-ray and 2 minimum for radiograph made with the gamma ray. For composite multi-film, each film composite shall have minimum 1.3. The maximum density shall be 4, either single or composite. That is closed book question. Then density variation, I told this is even last year they asked. The density of the radiograph anywhere throughout the area of interest shall not vary by more than minus 15 to or plus 30% from the density through the body of the designated hole type IQI adjacent to the essential holes. Now highlight the B also. When the requirements of A above are not met, then an additional IQA shall be used for each exceptional area and the radiograph retaken. We have to again radiograph. Doing additional IQA. You have to keep 2 IQAs and you have to radiograph. The next page, backscatter. This is important. If a light image of B appears on a darker background, forget about the background. You have to see the image. See, because answer they will confuse it. A light image on a darker background, a dark image on a lighter background. So forget about the background. Only see the image, B image. A light image, the radiograph protection from backside is insufficient and the radiograph shall be considered unacceptable. A dark image of the B on the lighter background is not cause for rejection. That is closed book question. Now, radiographic documentation. This is also open book. In radiographic report, what are the things you should write? Mandately, you should write in the, see, how the question will be asked. When reviewing the radiographs, the document should include all of the following except. So you have to see the list. What is missing? You have to find out. So there is documentation. Again, it is a open book. So that's all radiography here. But we have 577 also radiography there. Then we will go to the Article 6. PT.
6 basic steps. Prepare the surface of the patch. In this case, a portion of a welded joint. Solvency of cleaning directly to the surface. Surface is then wiped clean with a lint-free cloth. The second step, the penetrant is applied to the component by spraying. The component is a weld. As in this case, the penetrant is applied at 5 millimeters on either side of the weld to ensure compression. Following the application of the penetrant, sufficient dwell time must be allowed for the penetrant to enter any discontinuity which is to the surface. Dwell time, the third step in the process, will be recorded in the procedure, but is normally 7 to 10 minutes. Dwell time is passed before application of the developer. The penetrant must be removed. This is towel or cloth trimmings most of the penetrant. Following this, the surface is wiped clean with the cloth, which is lightly constant solvent. The surface should not be sprayed directly with a remover, as this could wash the penetrant out of shallow discontinuities. The component is now ready to receive the developer. Developer's suspension, aerosol.
Okay. So PT generally will have one question in AP exams. Only one question they are asking based on the PT. Just 10 points, around 10 points. What is the basic principle of penetrant testing? Capillary action, point number 1. Which material we can detect PT? So defects, which defects we can use for, we can use PT? Defects open to surface in non-porous material. So defects open to surface in a non-porous material, point number 2. Now, how many techniques we have in PT? We have 3 techniques. Okay. What are the 3 techniques? Solvent removable, water washable, and post emulsifiable. Okay. So what are the basic steps? You've seen the video. We have to pre-clean it, then apply the penetrant. Then you have to give some time. The time is called as dual time. After dual time, you have to remove the excess penetrant. Then you have to apply the developer and we go to inspection. Now the next one is, what should be the inspection time? 10 minutes to 60 minutes. That is the inspection time. We should not start inspection when you apply developer. As you can see immediately indication, but you have to wait for 10 minutes to measure the indication for evaluation, but a maximum 60 minutes. Which one? No, dual time. There is a table is given. Table is given. That is a minimum time. Okay, you can take. See, for example, dual time minimum is 5 minutes actually. If you give extra time, there is no negative or no positive also. But the only thing that the penetrant should not dry. Okay, dry means very difficult to remove. Then you have to make it wet before removing. Now, what are the other things you should know? What is the surface temperature? Very, very important. 40 to 125 degrees Fahrenheit. Point number 1. If you want to do PT more than this temperature, then you have to qualify the procedure again. PT requires procedure as well as procedure qualification. When procedure qualification comes, there are essential variable and non-essential variable. NDT also have essential and non-essential. There is a table is given. Sometimes they can ask in the open book, which of the following is the essential variable for penetrant testing? You have to refer the table and answer it. Then another one, we have major two techniques. One is the color contrast, another one is the fluorescent. Color contrast will form a red color indication on a white background. Fluorescent will form a yellow-green color indication on a darker background. Now, what are the important things about the color contrast? What should be the light intensity at the surface? 100 foot candles or 1000 lux. Before we used to say, now they rounded it 1076 lux, exact value, minimum intensity. If you go to the fluorescent, it should be in a darkened room. So maximum light, white light allowed is only 21.5 lux or 2 foot candles. But you need a separate light to view the indication that is called as a ultraviolet A light. Before it was called as a black light. Now they removed the terminology from section 5. It is ultraviolet A light. What should be the intensity of ultraviolet A light? Minimum 1000 microwatt per centimeter square. Now the next one is important. Eye adaptation time. You should not start inspection immediately. You have to wait for how many minutes? At least 5 minutes. And another one, you have to check the intensity, whether it reaches the 1000 before start of the exam, at the end of the exam, in between any power disruptions are there, then again you have to check whether the intensity, because if the intensity is not there, you will not see the indication. Then finally, when you are doing a nickel alloys, sulfur content should be less than 0.1%. When you are doing stainless steel, austenitic stainless steel or duplex stainless steel, chlorine, halogen, we call it the chlorine, their content should be less than 0.1%. So these are the key points. Okay. Generally, there will be one question based on the PT in the exam. So please take this. Highlight this one. Close book question. Surface preparation. Prior to each liquid current examination, the surface to be examined and all adjacent areas at least 1 inch shall be dry and free from all dirt, grease, lint, scale, welding flux, spatter, all these things. That is close book. You have to clean 1 inch on both sides. Close book question. Next page. So this is the essential variable, non-essential variable table. Just to mark it as a open book. Then techniques, highlight this one. Either a color contrast or a fluorescent pattern shall be used with one of the following 3 pattern techniques: water washable, post emulsible, solvent removal. But the exam question will be based on solvent removal only. The next page, this is very important. As a standard technique, the temperature of the penetrant and the surface of that process will not below 40 nor above 125. That is closed book question. First 3-4 lines. Then techniques for non-standard temperature. This is also closed book question. When it is not practical to conduct a liquid penetrant within the temperature of 40 to 125, the examination at the proposed lower or higher temperature requires the qualification of penetrant and the processing. That is closed book. Then calibration. Closed book. Light meters, both visible and fluorescent, shall be calibrated at least once a year or whenever the meter has been repaired. If meters have not been used for 1 year or more, calibration shall be done before being. So every year you have to calibrate. Then these are not important. Next page, this is a dwell time table. But this table exam, they are not asking. So you can see here, if you take steel, minimum 5 minutes you have to give. But there is a temperature limit here. This table is from 50 to 125. What is the temperature allowed? 40 to 125. So 40 to 50, you have to give the double time actually. You can see here, for temperature range from 50 to 125, for temperature from 40 to 50, minimum penetrant dwell time shall be 2 times of the value listed. Then this is important, solvent removal penetrants. Excess solvent removal penetrant shall be removed by wiping with a clean, dry, lint-free cloth or absorbent paper, repeating the operation until most traces of the penetrant have been removed. The remaining traces shall be removed by wiping the surface with a cloth or absorbent paper lightly moistened with the solvent. That is closed book. இதுதான்.
The table.
See, general law, we have to give minimum. For example, steels, weld, we have to give 5 minutes. But what the temperature allowed for penitent is 40 to 125. I will put it like this, 5 to 52 degrees centigrade. But this table is prepared for 10 to 52 degrees centigrade. Suppose your temperature is 5 to 10. Then you have to, instead of 5 minutes, you have to give the double time. 5 minutes means you have to give 10 minutes. You can see here, for temperature 10 to 52, that is the table value. For temperature from 5 to 10 degree, minimum penitent dwell time shall be 2 times of the value listed. So instead of 5 minutes, you have to give minimum 10 minutes. That is the meaning of it.
Yes, sir. 9 to specific.
The Clayle spec always overrule codes if they are more stringent than codes. Suppose code is more stringent than owner spec, we have to follow code. There are two things. What is written in the contract? Generally, they will write in the contract for NDT follow section 5 as well as owner specification. So you have to satisfy which is more stringent. Now, next page, highlight this one, final interpretation. Final interpretation shall be made not less than 10 minutes, not more than 60 minutes after the requirements are satisfied. So 10 to 60 minutes, that is the final interpretation. That is closed book question. Then color contrast, the minimum light intent shall be 100-foot candle, 1076, that is closed book. Then fluorescent, with the fluorescent penitent, the process is essentially same, with the exception that the examination is performed using ultraviolet called UVA light, that is closed book. Then B is closed book. Examiner shall be in the darkened area at least 5 minutes prior to perform examination to enable their eyes to adopt the dark viewing, that is closed book. Then D, highlight the D. UVA light shall achieve the minimum 1000 microwatt per centimeter squared on the surface or the part being examined. Then this is open book. F, the UVA light intent shall be measured with a UVA light meter prior to use. Whenever the light power source is interrupted, and at the completion of the examination of the series of exam, that is open book. Then these are not important. The next page, appendix 2, nickel based alloys, highlight this one, last line. Sulfur content shall not exceed 0.1% by weight, and austenitic duplex or titanium, this is closed book. The total chlorine or fluorine content shall not exceed 0.1% by weight. Right. Now, we will go to the MT Article 7.
It's simple. What you use an electron? First, the surface to be tested is examined. Wider. This process This magnetic field.
So this is the yoke. And this is the prod. Only yoke and prod is part of our exam. And you should know these things also.
Satisfactory field strength.
AC lift 4.5 close. This is the DC lift.
Satisfactory field strength. Permanent magnet. Able to lift this.
But what is here stamped here? 18.55. So code specifically say what is the nominal weight you have to stamp. Even though 18 close is the minimum. Okay, then. Now, one more. So this is 5 kg. How many lines will have 5 kg? 8 lines. Okay, it will have 8 lines. Right. So Article 7 talks about PT. Now, what are the key points in PT? First, what is the basic principle of PT? I asked the basic principle. Magnetic flux leakage detection. Okay. Which metal we can do PT? Only ferromagnetic materials. Now, PT, we have 5 techniques actually. Prod, yoke, headshot, central conductor, and coil. But the exam body of knowledge, it is only yoke and prod, and generally they will ask yoke. Okay. First thing, PT required, sorry, MT required procedure, and you have to qualify the procedure. So we need essential variable as well as non-essential variable. Now coming to the yoke, because generally current adjustment is not possible. So how we will check the field adequacy by lifting capacity test? AC yoke must lift 4.5 kg close. DC yoke as well as permanent magnet 18 close. Actual nominal weight we have to stamp on the weight. Okay, if it is 19 close, we have to stamp 19 close. Minimum only 18 close this one. Now what should be the yoke spacing? 3 inches to 8 inches. Minimum 3 inches to 8 inches. Then coming to the prod also, the spacing is 3 inches to 8 inches. But the prod, we have to adjust the current. Prod, we have to adjust the current. That's why we will have a ammeter in the equipment. How much current deviation is allowed in the prod? It is again regularly asked, plus or minus 10% of the value. Suppose the meter shows 300 amps. Actual value should be 270 to 330. Within that 10 plus or minus 10%, it is allowed. Now coming to the powder, we have dry powders as well as we have a wet particles. Wet particles, we have non-fluorescent as well as the fluorescent. The fluorescent, all PT requirements will repeat. Another one regarding the pi cage. Pi cage will have 8 lines. One side we can see the line. One side is the copper coated. So we have to keep the copper coated side on the top side and apply the powder on the copper coated side. If you use other indicators, like we called as a BC strips, Burma Castrol strips, other indicators, the requirement is at least one line should be perpendicular to the magnetic field. Okay. Now, another one more important, in MPI, we are using two types of current. One is alternating current, another one is the direct current. Now, what is the characteristic of AC is skin effect. It have the characteristic called skin effect. Skin effect means the current will travel only on the surface. DC does not have a skin effect problem. So AC can detect only surface defect. Because of the skin effect, because DC does not have skin effect, it can detect surface and subsurface effect. Now, how the surface defect will be? They will be sharp and distinct.
ராஜேஷ் வந்திருக்காங்க பாஸ் பண்ணுங்க
For 2 minutes. For a distinct. Whereas here surface will be same, subsurface will be wide and fuzzy. So what is the best method? AC wet. Here it will be DC dry. Right. Pass panningappa. Okay. So just we will hold and we'll have a break. After break we'll continue. இல்ல அந்த எலக்ட்ரிஷியன் இந்த இது மாத்துறதுக்கு வந்திருக்காரு. ஆமா டெம்ப்ளேச்சர் மாத்தல நீங்க பக்க போறோம். ஹலோ Please like this. ஆன் பண்ணிட்டியா அப்ப ரெக்கார்டிங்?
பண்ணிட்டேன் சார்.
ஓகே. இப்படியா? இந்த லைட் எரியுதா மேல? Okay, please take Article 7. Right, highlight the first 3 lines. The magnetic particle examination method is applied to detect cracks and other discontinuities on the surface of the ferromagnetic material. That is important. Then this one, whichever the technique is used to produce the magnetic flux in the part, maximum sensitivity will be linear discontinuities oriented perpendicular to the line. So please remember, the defect direction should be perpendicular to the flux, then only it will detect. For example, if you are saying, see, this is yoke. So this is the flux, will go like this. So your defect should be perpendicular to this, then only it will detect. That's why generally we are doing on 2 directions. That's why we have to detect all type of defects. So this is very important. Highlight this one. Whichever technique is used, the magnetic part maximum sensitivity to linear discontinuity oriented perpendicular to the line of flux. That's why for optimum effectiveness, each area to be examined at least twice with the lines of flux during one examination being perpendicular to the other. So that's why we are doing two this. Now, this one I forgot to tell because again telling, see, what is the temperature limit for PT?
10 to
5 to 52 degrees centigrade or Fahrenheit 40 to 125 degrees Fahrenheit. For MPI, we have to follow manufacturer recommendation. There is no limit specified in the code. Which manufacturer means not the equipment manufacturer, particle manufacturer. Dry powder means they will recommend what is the maximum temperature we can use. Wet means what is the maximum. So highlight this one. Temperature limitation, particles shall be used within the temperature range set by the manufacturer. Alternatively, particles may be used outside the manufacturer recommendation, provided the procedure is qualified. That is closed book question. The next page, procedure, we have essential variable as well as non-essential variable. Just to mark it as a open book. Then we have 5 magnetization technique. Highlight this one. One or more 5 magnetic techniques shall be used. Prod, this all these things, but these are not important. The next page, prod spacing. This is closed book question. This one, prod spacing shall not exceed 8 inches. Shorter spacing may be used to accommodate the geometric limitation of the area being examined to increase sensitivity, but the prod spacing of less than 3 inches are usually not practical due to banding. Then straight away go to the page number 238. Now, 238. In magnetic MPI, there is one is called multi-directional magnetization. So, for example, a large casting, if you want to magnetize, they will put a coil on all around and sequentially they will operate. That is called multi-directional. When you are using multi-directional magnetization, Hall effect probe should not be used. Hall effect is check the field strength. Highlight this one. This was asked in the open book. A Hall effect probe Gauss meter shall not be used to measure the field adequacy for the multi-directional magnetization technique. These 3 lines are important. Open book question. Page number 238. Yeah, open book. That this frequency, this also closed book. Magnetizing equipment with an ammeter shall be calibrated at least once a year or whenever the equipment has been subject to major electric repair. So every year we have to calibrate the ammeter. So which standard you have to use? National standard. That is the next paragraph. The accuracy of unit meter shall be verified annually by equipment traceable to a national standard. And the tolerance, the unit meter reading shall not deviate more than plus or minus 10%. That is closed book question. That is closed book question. Then lifting power of yokes. Highlight the A. The magnetizing power of yoke shall be verified prior to use each day the FPCs. Every day you have to calibrate. See, if you take calibration, generally yearly once. That is the rule. There are 2 exceptions. Radiography densitometer every 3 months. Yokes we have to calibrate daily. Now,
Calculate பண்றத gauge அதை calculate
இது
டெல்லி வந்து calculation
இந்த
with gauge they will calculate.
இல்ல லிஃப்டிங் கெப்பாசிட்டி தான். ஜஸ்ட் லிஃப்டிங் கெப்பாசிட்டி. அந்த
By gauge.
அது இல்ல, அது காலிபிரேஷன். அது வந்து ஃபீல்டு டைரக்ஷன். அது how to calibrate it? You can see here B. Each alternating current electromagnetic yoke shall have a lifting power of 4.5 kLs at the maximum pole spacing. C. Each direct current or permanent magnetic yoke shall be at least 18 kilos, 40 pounds at the maximum pole spacing. And D. Each weight shall be weighed with a scale from a reputable manufacturer and stencil with the applicable nominal weight. Actual weight you have to stamp it. You remember 18.55 means actual weight you have to stamp it. That is open to question. Now highlight this one, pie-shaped indicator, the A. The indicator shall be positioned on the surface to examine such that copper plated side is away from the inspected surface. That is important. Then artificial flaw sims, this one, the third line. Sims with the linear notches shall be oriented so that at least one notch is perpendicular to the applied magnetic field. That is open book question. So at least one notch should be perpendicular. Then these are not important. Please go to the page number 243. See, this almost repeat. The minimum light intent shall be 100 foot candles. And these are same only. So highlight the A, fluorescent. It shall be performed in a darkened area with the maximum ambient light, 2 foot candles. B, examiner shall be in the darkened area at least 5 minutes. That is closed book. And F, the UV light intent shall be measured with a UV light meter prior to use. That is open book. Now, yes, please. We are using a wet particles as well as dry powder. How you will apply a dry powder? By using a squeezing bulb. Wet particle, they will use a spray can. Dry powders are very difficult to apply in the overhead position. It is possible, but it is difficult. So what code says, if you are going to use a dry powder, you should qualify the procedure in the overhead position. So you ask the technician to apply the dry powder in the overhead. If he is able to apply in the overhead, like our welder qualification, he is qualified in all positions. Suppose he is only qualifying in the vertical position, he is not qualified for the overhead position. This is again regularly asked close book question. So please go to the page number appendix 2, page number 246. This one. When a dry powder technique is used, a compressed air powder blower shall be utilized for powder application in any position. Other applicators may be used if qualified in the same surface position as the examination of the object surface. Applicators qualified in the overhead may be used in any other position. Applicators qualified for the vertical may be used in the horizontal and flat. That means overhead they are not allowed. This is again close book question. Okay, this is empty. Then we'll go to the UT, page number 653, SC 797. Here may be one question. You remember this already we discussed. Python itself we discussed it. When you are using thickness gauging, we have to calibrate the equipment. Generally, how they will calibrate using a step edge. Which step you have to choose it? Because step edge will have 5 mm, 4 mm, like that, various steps. We have to use 2 steps in the step edge calibration block. One step should be the maximum what you are going to use. Maximum thickness you are going to measure. For example, your estimated maximum thickness is 10 mm. So 10 mm step you have to calibrate. Another one is what is the minimum you are expecting? First point. Second point, what is the basics of the thickness measurement? This is the formula for thickness measurement. Thickness is equal to velocity multiplied by transit time divided by. See, what is the ultrasonic basic principle? There are basic principle you will ask acoustic impedance. Okay. Practically, there are 2 principles. One is sound velocity is constant in a material. For example, steel. What is the ultrasound velocity in steel? 5920 meter per, say approximately 6000 meter per second. Water, 1500 meter per second. Air, 440 meter per second. From steel, 1/4 is water. Water, approximately 1/4 is the air. Okay. Now, that is the first point. Ultrasonic sound velocity is constant in a medium material. When the medium change, velocity will change. When the velocity will change, sound will reflected. Okay, this is the basis of the thickness measurement. We are sending sound through the steel. At the end of the steel, there is a air. Medium changes, sound is reflected. So if you know the velocity, transit time means going and return back. Then divided by 2 because we are want to measure the thickness. That is the basis of the thickness measurement. Next one is the calibration block temperature and the where you are going to measure the part. For example, take vessel. Temperature should be same. How much difference is allowed is 25 degree Fahrenheit can vary as per 577. After that, we'll go 577. But if the part temperature is less than 150 degree Fahrenheit, it is not a problem at all because there will be no different expansion. You remember 510 is given more than 150 only, we have to go for a temperature correction. I told you during 510 class, what is meant by temperature correction? We have 2 options. Calibrate the block at the higher temperature or every 100 degree different variation, reduce the measured thickness by 1%. This question is recently they asked in the exams. How the question will be if the UT thickness gauging is calibrated at 100 degree Fahrenheit or say 80 degree Fahrenheit and the part thickness should be 600 degree Fahrenheit. Part thickness is 600 degree Fahrenheit. Which of the correction factors should be used? Calibration 80. What is our part temperature? 600. So answer, they will give option. Option A. The measured thickness should be reduced by 6%. Option B. Measured thickness should be increased by 6%. Option C. Measured thickness should be reduced by 5%. Option D. Measured thickness should be reduced by 6%. Which is the correct answer? So I will write option. Option A. Increase the measured thickness 6%. B, increase 5%. C, reduce the measured thickness 5%. D, reduce the measured thickness by 6%. So this is the correct answer. We have to reduce. First, you should see the difference between these. What is the difference here? 520. If you round it, it is 500. So measured thickness should be reduced by 5%. Every 100 degree Fahrenheit, 1% you have to reduce. See, for example, if your measured thickness is 10 mm here, if you reduce 5 mm, so minus 0.5, it will be 9.5 mm. This is the way you have to do it. Okay. Another one, what is the maximum temperature we can do UT thickness gauging? Normally, what we are using probes, they can withstand up to 200 degree Fahrenheit, but there are hot probes are available, high temperature, we can use up to 1000 degree Fahrenheit. Only these 2 points are in SE 797. So please take SE 797, highlight this one. This practice provides guidelines for measuring the thickness of material using the contact pulse echo method at temperature not exceed 200 degree Fahrenheit. Then this is the formula, highlight this one. Thickness when measured by the pulse echo method is a product of velocity and 1/2 of the transit time. T is equal to Vt by 2. Then please go to the page number 656, 8.2.21. Use 8.2.21, page number 656. Use at least 2 standardization blocks. One should have a thickness near the maximum of the range to be measured, and the other block near the minimum thickness. One is maximum, other one is the minimum thickness. Then actually this is the one paragraph is important for exam point of view. 658. High temperature materials up to 1000 degree Fahrenheit can be measured with the specially designed instruments with the high temperature compensation. So up to 1000 we can use. Then 1, 2, 3, 4, 5, fifth line. A rule of thumb often used as follows: the apparent thickness reading obtained from the steel walls having elevated temperature is high by a factor of 1% per 100 degree Fahrenheit. Thus, if the instrument was standardized on a piece of equipment, say 68 degree Fahrenheit, and if the reading was obtained with the surface 860, the apparent reading should be reduced by 8%. So 860 minus 68, approximately 800. This is closed book question. Okay, that's all section 5. Right. So we will go to the 577. Please take 577.